Welcome to Maths Hub S. Today is another day and we are going to continue our lessons. The topic that we are looking at is indices and logarithm. Specifically, we are going to start with indices. So if we start with indices, we get a concept of indices, and we also look at logarithm and how the two, that is indices and logarithm, are related. So today we are going to look at indices. Let us start with the concept of indices. Concept of indices. Why is the concept of indices, or why was the concept of indices introduced? Supposing that I want to multiply a number by itself a number of times. For example, I want to multiply 2 by itself 3 times. So I can do 2 times 2 times 2. This is 2 multiplying itself 3 times. Now I want to multiply 2 by itself, let's say 10 times. So I have 2 times 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 2. So this one is 2 multiply itself 10 times. Now supposing that we want to multiply 2 by itself 100 times, then we are going to get 2 times 2 times 2 times 2 times 2. Then we continue on until we get to 99, then 100. So you see that basically at this place I've decided to introduce 3 dots, which means that I've skipped some of the multiplication simply because it's difficult. Multiplying 2 by itself 100 times is not an easy task. You have a lot to write. What about if you want to multiply 2 by itself, let's say 1000 times? You see that the situation gets even worse. That's why mathematicians decided to introduce what we call indices, so that this 2 multiplying itself 3 times, the first one here, which is 2 multiplying itself 3 times, we can simply say that this one is equal to 2. Then multiplying itself by 3 times, we write the 3 as an exponent or as an index. We write it as an index. This one here means that 2 is multiplying itself 3 times. Now the second one here, which is 2 multiplying itself 10 times, we can simply say that this one is 2 multiplying itself 10 times. So we write the 10 as an exponent like this, meaning that 2 is multiplying itself 10 times. Then here we have 2 multiplying itself 100 times. So we write 2 then multiply itself 100 times like this. Right. So at this point, if we consider what we have here, you see that we have 2 main components of this compound number. You can see one of the components is 10 and then the other one is 2, right? The 2, which is 2 exponent 10, the 2 is called base. We call the 2 base, and then the number on top, the 10 on top, or whatever number that is on top, that number we call it index. We call it index or exponent. Exponent. Index or exponent. So basically we have 2 called the base, then we have 10 to be the index or exponent or the power of the compound number that we have here. Right, so here we call 2 the base, and it's reasonable because the 2 is the main target and 10 is telling us that we are multiplying 2 by itself 10 times. So basically if we are writing, 10 will not appear but 2 will appear. You see 2 times 2 times 2. So 2 is the base. We are basing on 2, not the 10. So we call 2 the base, and then the 10 is the index or the exponent, telling us the number of times that we are multiplying the 2 by itself. Right. So if we come here, the same 10 as you can see here, 100 is the exponent, and then we have 2 is the base here, And then here 3 is the exponent stroke index stroke power, and then 2 is the base, which means that any number at all, or any compound number at all that you have, the down one is the base, and then the number on top is the exponent or the index, right? Let us move on to what we call the laws of indices. And the laws of indices will help us to solve or simplify numbers involving indices or questions involving indices, and also solve equations involving indices. So we are going to move on to the laws of indices. So we have laws of indices. The laws of indices, as I said earlier, help us to solve questions involving indices, and they are very, very important, which you need to know if only you want to solve or you want to understand indices. Then you have to understand how the laws work. Once you understand how the laws work, then you can apply it anytime that you want to. So our first law of indices, our law 1, is saying that a exponent m is multiplying by a exponent n, and we are going to get a m plus n. And note that these are variables. The alphabets, we call them variables. We use them to represent numbers. So the a, which is down here, this a is the same a here, and we call that number the base. So this is the base, and here we call this one the same base, so it's same base. Then here too, this a2 is same base. It's the same base, a throughout. So we have here the base is a, we have the same base a, same base a. So the bases are the same. Simply put, the bases are the same. So basically the variables are simply numbers. So for instance, if I have 2 exponent 3, the a stands for the 2, and then the m stands for the 3. Then if I'm multiplying this one by, let's say, 2 exponent 5, then as I said, the a is the 2, then we have the n being the 5, right? So you can see that the bases are the same. We have, that's why I wrote here same base, same base, same base. So the bases are actually the same. So here is 2, and then here 2 is 2, and then we have the answer aspect. The answer is saying that you have a, as you can see here, you have a, so that means we have 2. Then we have bracket m. M is the number here, which is, in this case, which is 3 here. So that is m. You can write 3, then plus n, which is this one here, so plus 5. 3 plus 5 is 8, so we have 2 exponent 8, which means that 2 exponent 3 times 2 exponent 5 is going to give you 2 exponent 8 as your answer. So to make it simple, we are simply saying that if you have numbers multiplying or indices and they are multiplying, check to see that the bases are the same. Once the bases are the same, then the answer is pick the base, which is here, pick the base, and then add the index, that is, add the index m and n, which is here m plus n. You can see it clearly here too. We have 2 and we have 2. The bases are the same, 2, 2. Therefore, to get the answer, pick your 2, and then the index of the answer is the index of this one here plus the index of this one here, and you are going to get 8. We further want to explain the law. So let's look at this one here. Supposing that I have 4 times 8. 4 times 8 is going to give me 32. So we can rewrite 4 in terms of 2 as 2 times 2. Then we bring this multiplication here, this one. So 2 times 2 times 8. And 8, we can write 8 as 2 times 2 times 2 3 times. Then our answer is 32. 32 2 in terms of 2 will be 2 times itself 5 times. Two multiply itself 5 times, that's 32. So now we want to put this one in the form of indices. So that is 2 multiply itself, and we can say that this is 2 exponent 2 because we have 2 multiplying itself, so 2 and 2, that is 2 exponent 2. Then this side we have 2 multiplying itself 3 times, so we can bring our multiplication, which is here. So we have times, then 2, this side multiplying itself 3 times, so we have 2 exponent 3, and then the answer is 2 multiplying itself 5 times, so we have 5 from here. Right, so by observation you can see that the exponent of the answer is 5, and this 5 is the same as just adding 2 to that of 3, and you get the 5. And know that the bases are the same throughout. So that is why we are saying that if you have AM times AN, then your answer is, once the bases are the same, AA, then your answer is A, then add the exponents. So you have M plus N. And this is the first law of indices. Now we move on to the second one. We have law 2. Is saying that if you have A exponent M dividing by A exponent N, so you are going to get A, then M minus N as your exponent. And this is clearly, you can see this is division. We are talking about division here. A exponent M divided by A exponent N is equal to A, then you have M minus N. That is the exponent of the numerator minus the exponent of the denominator becomes the exponent for your answer. And note that the answer has the same base as the A's here. You can see they are the same. A, and A, they are the same throughout. Right. So let's look at some examples here. Example, if you have 3 exponent 7 divided by 3 exponent 5, then this one you are going to get 3. The base of the answer is the same as the base of the numerator and that of the denominator. So here we have 3 as the base. Therefore, the base for the answer will also be 3. Then we have the exponent of the answer is the exponent of the numerator, which is 7, minus the exponent of the denominator, which is 5. That is M minus N, as you can see here. And this means that we are going to get 3, then 7 minus 5 is 2. So we are getting, and this one simply means that 3 is multiplying itself 3, and that means that we have 9 as our answer. Right. So this is one example on the laws of indices. Then we proceed. Example 2. If I have 2 exponent 3 dividing by 2 exponent 5, then we are going to get 2, then we are getting 3. That is the index or the exponent of the numerator is 3. minus the index or exponent of the denominator, which is 5. So finally we are getting 2, and then 3 minus 5 is negative 2, so we have negative 2. And this one, we will come to another law which will explain this, but this one simply means 1 over 2 exponent 2, and this is equal to 1. Then 2 exponent 2 means 2 times 2, and that means 1 over 4, right? So we are getting 1 over 4 from there. We want to explain this law further. Supposing that I have 16 divided by 4, this one basically will give me 4. Now we can rewrite the 16 in terms of 2 as 2 times 2, that is 4, times 2, 8, times 2, 16. Then the 4, we can write it as 2 times 2, that is in terms of 2. Then equal to 4. That one too, we can write it as 2 times 2. Right. Now we want to put them in the form of indices. So the numerator, which is the 16, becomes 2 exponent 4, which means that 2 is multiplying itself 4 times, as you can see here. So we have 2 exponent 4. Then we have dividing by 2 exponent 2, which is 2, which means that 2 is multiplying itself. And then this is equal to the answer that we had is 4, which is also 2 exponent 2. Now at this point, by observation, if we look at the index here, it is 4. Then the index here, it is 2. And then the index of the answer is also 2. So you can simply see that the index of the answer is coming from the index of the numerator, which is 4, minus the index of the denominator, which is 2. And then you have the 2, which is here. That's why we are saying that if you have AM over AN, then your answer is going to be A as the base for the answer. Then the exponent of the answer will be M minus N. As you can see here, the 2 here is coming from 4 minus 2 down here. And then you have this one for that. So that is the second law. Then we move on to our next one. Now the next law, can call it law 3, is if I have A, B, then exponent M, this one is simply equal to A, M, then B, M. For example, if we have 2 times 3, all exponents, let's say 5, then this one is going to give us 2 exponent 5, then times 3 exponent 5. That is what the third law is basically saying. So you have this one. Then we look at 4. If you have AN exponent M, then this one is equal to A, N, then M. And we can look at an example on that. Is you have 7 exponent 3, all exponent 2, then you are going to get 7, then the 3 times the 2 top, and that is going to be 7 exponent 6. We are basically saying that just multiply the exponent here, which is a 3, by the exponent here. And that is that law which we have here. A, then we have NM. We have another property or law, and let's call that 5. And that is, if you have A over B exponent N, this is going to give you A exponent N over B exponent n. And an example on that is supposing that you have 7 and then you have 3 all exponent 2, then this one is going to give you 7 exponent 2, then 3 exponent 2, and then you can further simplify. So 7 exponent 2 means 7 times 7, and that is 49. So finally you are getting 49 then on 9. 3 times 3 is 9, so you are getting that. And that is that law. So we can look at law 6 or property 6, and that is if you have a exponent negative n, this is going to give you 1 over a exponent n. And we can give an example like if you have 3 exponent 2, this is going to give you 1 over 3 and then 2, and this is going to give you 1 over 3 exponent 2 means 3 times 3, and that is 9. So we end the lesson here on the properties. Later when we come, we continue from where we've gotten to. Don't forget to subscribe to the channel. Also like and share the video. Thanks, and see you next time.